Hello, how you doing, Bridgewater? I don't think I've played that game. I guess it's like a. I guess that's a game. Are we there yet? I haven't played it. But how you doing? welcome. So I did do a little bit more thinking about collisions and things. And I think I've got an overall idea of how I want to handle it. So we're gonna find out if it actually works or not today. But for starters, I'm gonna make it climb up the walls because that's the easier one of the two. Opposed to the bricks. I think I've got it. Like I said, I think I got it figured out. I was actually jotting some stuff down at like 2 in the morning yesterday. This morning, whenever. I don't know. How does time work again? So I might get to that, I'll hopefully get to that later. Hopefully after we have some things bouncing around. But yeah, oh yeah, and I was actually working on some other housekeeping related stuff, I guess. I'm trying something a little different. I modified the make file a little bit. Yeah, there's fewer, well, not really fewer lines, but I mean, some of them kind of are. I'm trying it out where I split the program code and the data into their own object files, and then link them together at the end. This might complicate things unbelievably. We'll find out. I might regret this later, but I mean, you know, whatever. It's all a big learning experience, right? And one thing I do want to do that I forgot to do earlier is fix some syntax highlighting. So let's do that real quick. Vim files. Really? Oh, I gotta edit. Vim files, syntax, CA, yada yada. Okay. I really need to like revisit this syntax highlighting because it doesn't really work the way I want it to. I don't account a programmer has been properly seasoned. It's been burned by his own clever. Yeah, I mean there is a bit of truth to that. Where is this? Oh, here they are, down here. I think there's a bit of truth to that. Some keyword, was it import and export? I think. Yeah. Pre-proc words contained. Oh right, because yeah, right. Export CP, import and import CP, and we're gonna go down to. What do you mean you can't? What? Oh, because regex. That's why. No, not that one. Let's take this one. Yeah. Well, no. Match ASM pre-proc. Bear with me for a minute here while I regex things up. Contain, yes, absolutely. Import dot plus contains that as well as ASM label. There we go. Set sin equals CA 65. Fixed it. Beautiful. All right. So now that I've got that out of the way, so this is importing and in other places exporting symbols that I define in different places. These specifically are checks, are written by my map conversion stuff. I didn't do that on stream. I figured it out after. Well, I didn't figure it out. I wrote it after stream. Subhuman Potato, how you doing? Factorial Server 1. I see. So like, I feel like I'm still getting like my feet wet in that game. Honestly, there's so much to do in that game. It's almost overwhelming. But how you doing? And Lieutenant Junior, how you doing? Is it Lieutenant? I forget. I think it was. Okay. Factorio. It's a time sink. That's the game it is. I've been playing that a lot over the past few days. Like a lot more than I probably should be. Anyway, more of it. Yes, I would say so. Absolutely. Okay, I did. All right. My memory is crap. So, but yeah. So I've got the data width and height that are set by the map export, and those are checked against the board width and board height that the code expects. After I wrote this, I'm like, wait a minute, can't I just like define that? Define what it's supposed to be in the code export, and just because everything is a constant, right? It's not hard coded in. It's all in a variable somewhere. I think the only spot I would have issues is with right here. But if I do like, you know, I haven't actually tried this yet, so let's try this real quick. What was it? Board width, board data length equals board width times board height. Can I put that? I don't think I can, but I'm gonna try anyway. Cause it wouldn't let me do this before. It didn't recompile it. Yes, it did. Wait. Can I? No, cause that. Well, hang on. That wasn't actually being assembled in. Oh. It might actually work. So what happens if I get rid of that, and that, and that, and that? Huh. So I guess I can't just, like... You know... Grab this, put it there. I can't do that, can I? I can do that. Why was it breaking before? Is it because I did one of these? Is that why? Oops. Okay. Okay. I see how it is. I see how it is. Funny color on the N. That's my syntax highlighting breaking. That's what that is. Immediate value. It's in there, the immediate value string, but it's not cooperating. Because I don't know. I think it's this that's screwing it up over here. Numbers rune. What was the other one? Like it was a math something or other. Oops. No. I thought it was like math or constant something or other. Instruction? No. Constant math, that right there. I think that's what's actually breaking it. Nope. I don't know. How you doing, Big? Welcome back. I don't know. It's something weird that I'll try. I might try and figure it off stream. I don't know. If someone wants to fix that for me, by the way, the code's up on GitHub. Anyway, so yeah, the first mode of bouncing I want to get working is single point collision. I'll be using that with the walls and the paddle at the bottom. There's also another mode of collision that I will be trying out. Yeah, let me actually draw it up here. So I'm gonna... Can I, like, move? Thank you. Grab this, move that up there. Why did it change the background color on me? There it goes. And for this, I'm actually gonna make this the ball 1 pixel larger, like that. So it's yeah. So we've got the center point there. And let me actually move it away from the edge by 1. So this is this center point right here is what I'll be checking for the walls and the paddle. But for the bricks, I'm going to be checking a different point. I'll put those in green. Different points, I think. I'm not 100% on their positions yet. But so I'm going to be checking the edges on at most two edges, depending on the direction of travel, for collision with a brick. And I figure that those points will be kind of like this around the ball. They won't be there in the sprite; they'll just be there in the math, really. So the idea is that the collision will happen. Oops, not off that one. There it goes. So the idea is that the collision will happen on here, or on here, or this. Whoop. Come on, stop that. Or this edge, or this bottom edge over here. But only 2 of these will ever be checked per frame, right? Depending on which way it's going. So if it's going up and to the left, it's only going to check these 2 points and then these 2 points over here, or probably the other way around. The vertical first, then horizontal. And by that, I'd be able to tell which side it bounced off of. Logical Insanity Gaming, how you doing? Over Piskel. I don't think I've used that one. Free online sprite editor. That's the no-no for me. Is an online sprite editor. I want a program like something I run on my machine. Yeah, I can't stand browser-based stuff at all. That, and I really like Sprite. And the way it handles files works very well with what I'm doing here. Yeah, I do not like using cloud-based software at all. A bunch of reasons. But the reason I'm using a Sprite specifically, though, is I really like it. And if I wanted to, I can script in exports for stuff and animations, and I'm not even using like a fraction of what this program can do. Yeah. But that's it's mostly preference for a lot of people, but yeah. But yeah, so I figure I'd be able to determine like which way. Hey, thank you for the host. Appreciate that. How you doing? I can figure out the direction it's coming from depending on which pair of collision points the ball collides with, right? Yeah. But we're not going to be working on those first. We're going to work on the center guy first. That would be a lot easier. It's kind of like a bounding box. Oh no! Sorry. Well, welcome. How you doing? Were you live today? How does it feel? Oh, no, this is nasty. Because it is. Okay. Thank you, Hayes. I appreciate that. How's your day going? Alright, so we're gonna actually undo a bunch of that. There it goes, okay. So I'm gonna put that there. So -2 on each side. So I need to change the math for that. So game. That's only a visual thing, but Jojo, thank you for the host. How you doing? Welcome. Alright, update ball chords. Oh, that's not it. I want the sprite. Should collide stuff. Where is that? Where is the sprite thing? Right sprites. It ain't gonna be in there. Ball chords. Oh. I don't do it at all, actually. I don't do any of the... Wait, no, what? Hang on, where do I... Oh, that's right here. Sprite coordinates. Yeah. Yeah, we're not subtracting 4, we're subtracting... like 2, right? Is that what I'm doing? No, I'm not. Hang on, should I be adding? No, because I'm calculating this point right here, the center point. Yes, I'm subtracting 2 from either direction. 2. It doesn't need to be centered in the tile, so whatever. Tired, yeah, I've been there. Your keyboard break there? All good things. Played Lords of Midnight. Died and played Master of Magic and died. Rip. Your debut in Overwatch. Oh boy. I haven't played that in a few weeks. Like, actually, about a month or two. 10-hour day. Yeah, that's a long day, I think. That's a long day. Alright, so I need to define a bounding box, essentially, of the walls. So let's where's yeah, this guy. Right. So I need to figure out where I want this to bounce. I'm using Dvorak myself. In fact, let's see if the keyboard will cooperate. It does. All right. This is my my keyboard layout right here. So it's not even vanilla Dvorak. It's programmer's Dvorak. You can see by the shenanigans going on up top on the top row there. Right, so like I said, so I need to find out where I want this to collide, and let's actually just open this up and drop a, well, not a breakpoint, but a watch. Oh, I've already got the watches there. Okay. Let me window that actually. Watch window. What was that, like OB? OA. Maybe. Thank you for that file, appreciate that. OA, I think. 0A. Or no. Let's actually have it collide at 9. At 09. Bloodborne. I'm gonna be changing a lot of this stuff here. So this is using the point in the middle, but to check if it's inside the bounding box of the board. I think I'm gonna change this or not even really use this later on. Sleepy Mia, how you doing? Welcome, welcome. Yeah, so I'm not. I'm gonna. We'll come back to that. Check. Wall collide. Even though it says just check, it's going to it's also going to act upon a collision. So it's not going to return like true or false or anything like that. It's gonna check it, and then if it collides, it's going to reverse the vector itself. Yeah. Completely offline. Was it a Sleepy Mia or a Sleepy Mia? Because that's Twin Mia right there. Right. So I want to take let's see, ball Y, and compare that to let's actually make these constants. Wall right, wall left, wall top, wall bottom. And the bottom one isn't actually going to be a wall, but whatever. What did I say? 09? Yeah, got him. I don't even have it. I don't have it open yet, so why am I looking for it? So let's do FF minus 09 F6. $sign F6. I said F6, right? You're right. All right, so this is basically just the same distance on the other side. All right, so how about top? I need the watch window. I'm sure there's an easy way to do this, but whatever. Actually, I know there is, with just modifying RAM a little bit. Come on, go up a little bit. 10. I think we'll go with 10. Alright, so this is going to be 10. And what's the bottommost that you can have? I don't even know. I don't think it matters. So I'm not gonna get to it. I could have just wrapped it around, but whatever. Oh shoot, I need to go the direction. What was that, DF? Yeah, DF, I think. Okay. DF. Okay. Oh, so for these as well, I only need to check two directions: the top and the bottom, or the vertical and then the horizontal stuff. So if I'm checking for the top wall, I don't need to be checking for the bottom wall, right? In theory. No. So I need to first off figure out which direction this ball is traveling. So we're gonna load up. I didn't need to actually. There it goes. And positive is going down, negative is going up. Yeah. So let's check negative first. So branch plus to going down. There we go. Compare that to, what did I say? Wall, top. I want to branch on something. I want to branch if it's greater than at this point. Where is? Oh, there it is. It's over here. I wonder if I. Clinton era vice president simulator. Yes to both. I'm gonna say. I'm gonna say yes to both. I'm not sure why I'm over here. I want to be over here and over here. One more. 150. There it goes. Compare CMP. Where are you? There it is. I went by the other table, didn't I? Yes, I did. All right. So if it is greater than, I want it to not collide. So if it's equal to or less than. So if yeah, if carry is clear, or if it's 0. Or yeah, branch equal to collide. The bounce rate. Branch on carry clear, right? Yes. Otherwise, we are jumping to check horizontal. Okay. And this is just going to reverse the speed on everything, which is just going to add 127, I think, to the number, because that'll roll it around, right? I might be off by 1, but I think that's about right. We'll see. And I can't be sure that carry will be clear at this point. The polarity of the neutron flow. Nagatoro-san? Nagatoro-san. Should I know what that is? I feel like I should. So we're going to clear the carry. We're going to add carry 127. Store that into ball Y. But I also need to change the fractional part as well, because it's going to be negative, but on the N2's complement mode. Was it in the cat suit with the sheep? Don't remember. I don't remember that one. Old School Doctor Who was amazing. There's a lot of it though, isn't there? Load up ball Y. I'm keeping the carry, aren't I? Am I keeping the carry? I think I'm keeping the carry. Probably. I'm probably keeping the carry. I don't know. We'll find out. Oh, that. I know what you mean now. Yeah. It's that was a good one. I did read it. I think it was today. Oh. So this is going to be the same, even if it's going down. So I can put that there. Compared to wall bottom. And this is going to be the opposite. So if it's equal to or less than. Equal to or greater than, excuse me. Equal to or greater than. So if carry is set, it bounces. So branch on carry clear to check horizontal. Otherwise, it falls into this and bounces. I think. I'm sorry, Jojo. I'm bad with names. You should know this by now. Okay. Check horizontal. Load up ball X plus 1. Branch plus. Now, if this one's plus, it's going to the right. Otherwise, it's going left. I know it because it's written right there. It's right off the screen over there. I can see it. Alright, so it's going left. So we're going to compare this to wall left. And if it is... well, the same. So if it's the same stuff as this here... well, I mean, it's going to be kind of similar. Horizontal. This one can just RTS actually. I can just return early there. I don't have to jump anywhere else. Akabaffin, how you doing? Gotta get up early to prepare for a couple interviews. All right, well, you have a good night, Hayes. Thank you for stopping by. Appreciate it. Good luck with the interviews. All right, bounce horizontal. This one is basically gonna take this and put it down there. You know, this doesn't actually sound right. Yeah, I don't think my math is right here at all. It's on Twitch. So I have a sinking feeling that this math is completely wrong. I want to see how wrong it is, though. I want to see how wrong it is. We'll see. So these need to be X, like that. But I'm pretty sure this math is wrong. So whatever. Going right. Compare this to wall right. Branch carry clear. To nowhere. Carry set. Bounce. Horizontal. Another turn early. Alright. Carry set is going to be equal to or greater than. Right. And that's when we want to bounce. Milwaukee, nothing better than failed math. Why does it fail? Why isn't the fine? Alright, so now I just need to put that in, what did I call it again? Check wall collide. I just need to put this in, the frame routine. Somewhere. Here. The frame game, where does it? Oh, okay. Update coordinates. So we're going to do it right after the chords. JSR to that. And yeah. Oh, and let's give the ball a speed at the very beginning. Do I actually, oh, right there, ball X and ball Y. So let's give it a speed of like 1.5, right? So yeah, not -2. No, 27 divided by 2, 63 in hex, 3F. Wait, no, that's that's the initial position. I want the speed. Where's the ball speed? I never set that. Okay. Fortunately, 6502 is onto the job. Cannoli adding and subtracting you ever need. All right. Store that into ball speed X and Y. And then we're going to load up 1. And store that into the other byte. Okay, so it should be traveling down into the right when it starts up. Let's see what happens. Yep, didn't collide though. That's neat. Let's slow it down a bit. Let's just make it 1 pixel per frame. Okay, it does go in there. Bounce vert and bounce horizontal. Do these ever happen? No. No, they do not. Well, this is no more than mine. Okay. So why was this failing? Let's get this down to somewhere. We're checking against 7F. E, 98, C, E, D. No, we're checking against DF, which is the next frame. But let's jump down here. So we should be going down, right? Why didn't it branch? I know why. I know why. So I'm checking a vector. Before that vector, I'm checking the coordinate, the position. Where is it? There it goes. So no. Load up ball speed Y plus 1. And then we check this stuff. And then None of that crap. Load up ball speed X plus 1 plus Y plus 1. And put that down there. And put that down there. Okay, let's try that again, shall we? It's not even drawn yet, and it's already checking. Ah, okay, here we go. Going down. What was the other one? Oh, that's an RTS. Going right. Okay, good. It hits both of them. That's good. See, it wasn't hitting either one of those before. That don't work. Because I'm changing the wrong things is what I'm doing. I'm changing the position instead of the speed. Try that again. Hey Trixon, how you doing? Welcome, welcome. Yeah, my breakout game's broken. Now you can't really see it very well, but the ball is in two places. Ball speed, ball speed. Ball speed, ball speed. I didn't store it anywhere. Ludicrous speed! Yeah. That happened probably Quantum. If this will be a household name, I don't know about that. This means you have multiplayer support already, right? Fudge Bin, how you doing? Welcome. Alright, so let's go ahead and reload that. I'll let it run at a quarter speed here so we can see exactly. Yeah, we can see the moment it breaks. Yeah, it's broken. That's for sure. Yeah. Nice, dude, win. No. So what do the speeds look like actually? Because that's what's changing. So the ball position is just flickering back and forth, whatever. That's not what I'm actually changing directly. What I'm changing directly are the ball speeds. So, you know, and oh, but it's +1. Okay, I thought I was changing the ball speeds, but it ain't. Did I not? It didn't reload, did it? Okay, 1 and 1. Oh, it's just moving really fast. So what we're gonna do, we are going to change the logic here. It was broken. Okay, so we're gonna load up that. Set carry. And subtract it twice. And then start it back. The The first subtract will get it down to 0. The second subtract will be the mirror of it, the opposite. Probably. Right? And let's ignore the horizontal for now. And just return early. Load 0, subtract that. Oh. Thank you, Bridgewater, for pointing out my incompetence. Yeah. I never said I was good at math. Shopping is hard, let's do math. Alright, yeah, so let's subtract from 0, because that makes more sense, actually. Load 0. Set carry. Oops. Subtract. Like that. Alright. Let's try that again, shall we? What do you know? When the math is right, it works. All right, I wanna subtract 1 off of the bottom and the right side. So ball right F5, ball bottom DE. Yeah, it collides and bounces. Who would have thought? Speed, let's do half speed. I did reload, right? I think it did. So those 2 walls look fine. But these 2 walls, I think, yeah, that goes in a little too far. Did it not change? Did I not change anything? Did it not change? Did I like not reload the ROM or something like that? No, check for DE. Wait a minute. Hey, what's the sprite limits on these guys? Or the coordinate limit. Hang on. Pretty sure I'm not there, but like, what am I checking against? Right? High DNA sprite writing values EF to FF. Okay, so I'm not there yet. Congratulations! Yay! Yeah, note to self: never do math on stream if you ever stream, right? Yeah. Or do it so people find your mistake and point it out to you. Crazy question. There's a month-long Metroidvania game jam on itch.io. Itch.io. Starting in about a month. What would it take for you to be able to make a Metroidvania on stream in a month? A lot of caffeine, I think. And I don't think I'd be able to do that in assembly in a month. That's for sure. And I don't think I'm very familiar. I'm not familiar enough with it with other engines to make it happen in that short of times in that short of a time span. Yeah, because there's a lot that would have to go into that, and I don't feel I'm prepared to do that. Let's try the C and 4. Okay, let's try this one now. So let's slow it down again so I can see when it collides here. Make it a little bigger to easier to see. Okay, that's better. Okay, see, so this is why, like, it doesn't look right. I never exported the the new image. Oops. Bring that back. Quick, where'd it go? Okay, so the bottom one is fine. I think I moved the right over a little bit too much. Yeah, the it hadn't updated the stuff yet. So that one overlaps by 1. That one overlaps by 1. All right, I want to add 1 to those 2, the top and the left. I think the bottom is fine now. Let's have a look here. Bottom is fine. That side isn't. Okay. So I'm adding 1 to all of them except the bottom. Right. It did underlap, yep. Really? Well, let's have a look. Break on scan line 240. What's frame? F8? F8. Goes to my 1, bounces. And by 1, bounces. Alright. So should I have it overlap by 1 pixel first and then bounce? Or so that one right there is right at right on the edge. It doesn't overlap at all. Turn it, do it again. Alright. What? Break on 240. That one was 1 too soon again. Okay. So let's add 1 more to all of them. Except the bottom one. Oh. 360p, yeah. Might be encoder stuff. I made it bigger though, so you can see a little better. All right. And let's go ahead and right in the virtual beam, pretty much. How you doing, by the way, Bahamut? Am I saying that right? I never know how to pronounce that word. Or name, I guess. Alright. It's aligned. Bounce. Good. Aligned. Embedded 1. I'm going the opposite direction now. Can't complain if others mess it up. Alright. Well, welcome. How you doing? No, don't make it big. Just go over there. What scan line one? What's scan line 154? I wanted it to break on like, you know, 240, and then I expect when I hit run frame, it goes back to scan line 240, which it does until it doesn't. The White Man, how you doing? Welcome. It says breakpoints. And that one was too soon. Okay. So I think I might have had it right before and I just never assembled. Yeah, I had it right before and I never assembled. That's what happened. So that's going back down to 11. Yeah, this one's going back to A, and this one's going back to 5. One at a time. Remake that, go over here, reload that. At least it's not a TV typewriter or a cheap video system where the CPU gets fed a bunch of no-effect instructions. I mean... Alright. Good bounce. Good bounce. Okay. Alright, so it's looking better this time. It's looking better this time. Good bounce. Good bounce. Okay. So let's see what happens when I increase that speed to something else. I need to actually edit that in the memory though. Ball X, no, ball speed X. Does it end up embedded in the walls? It shouldn't, in theory. I mean, if it's going fast enough, it would clip around. It would wrap all the way around. Oh, let's make this a bit smaller. Video size 2x. So this one right here, ball speed X. This one, okay. So I'm gonna wait for that to flip around, then I'll make that 2. Or just, I'll just do it here. Okay. It does embed a little bit. All right. 4? Yes, it does embed. Embed. I don't want it to do that. Instead, I think I want it to look at it at its previous position. Particle Collider Simulator. So I think I want it to look at its previous position and subtract that, or yeah. I wanted to find out how far it's embedding into the wall, and add that to how far it should be away from the wall next frame. Or actually that frame. Yeah. Right? So with that, I might actually want to split out the update coordinates and update sprite. Because this would be like move ball essentially, or apply speed to ball. But I might want to arbitrarily move the ball outside of the speed, like when you bounce. To, like, you know, for where it ends up after the bounce. I think I went over this before, a stream or two ago. You guys get what I'm saying, though? So I did clean this up a little while ago, but now there's, like, wires again. Here's the one I want, this one. Bum ba bum. Also, I think a particle collider simulator would be quite difficult to do, especially on the 65 Voto. Especially on this Windows. Come on, you know this. You know what this is. Why do you gotta look? Windows, you know what it is because it works. Why you gotta install drivers for something that works? Windows, what are you smoking, Windows? Let's see if Control Z works. No. No, it don't. Okay. There was an extra icon for OBS down there. I'm gonna check real quick to make sure the OBS isn't still running. Or if the second instance isn't still running. Probably isn't, but I don't know how I'd be able to check actually. Because it's... Oh no, okay, we're good. We're good. Thank you for that follow, appreciate that. If ball speed x is greater than ball x, then ball x plus equals... I mean... What? Should we paint.net? This is literally just something for me to scratch on. That's all that is. Yes, apply. And now... Oh look, Control Z works again. But basically what I'm getting at anyway. So that's the wall, right? You got the ball coming this direction. And say the collide happens, it checks for the collide when it's like way over here, right? Inside the wall. So currently it'll bounce from there and continue on its way, right? In this direction. But I don't want it to do that. Instead, I want it to bounce here essentially and take this distance right here and add it from this point over here, right? So instead of being down here somewhere, instead the ball will be, you know, over here somewhere, right? Or more realistically, like there, right there next frame, go in that direction. This is not math, this is physics. I mean, oh, scratch, it should be a turntable. We were too close to the wall, let's go back already. Yeah, right? Yeah, so I would actually need to... Well, no, so the horizontal position is still going to be the same, right? So the horizontal distance it covers, oops, is still going to be, you know, lining up with each other. It's just going to be the horizontal position. Physics chose math every time. Well, they're both like, you know, kind of one and the same. Well, physics needs math, I guess. Right? Yeah, math doesn't necessarily need physics, does it? All right. So if I take the position once it collides and subtract the wall from it, right? The wall position, the wall value. I will get the I will get just this number here. And that number I can just add on to the x coordinate of the ball. Right? Right. What happens if I do this in a corner? Good question. I don't know. We'll find out. We'll find out when we get there, I think. You know, let's see if we can test that real quick. Yeah, so let's make ball speed 0. Zero, 0. Okay. Sleeping, address pointer stuff. No, where's the Okay. 10, let's go B? No. 0, B. So we are 1 pixel away from the wall there. And what was the top again? I'll collide with the upper left corner. What happens if the ball's moving fast enough to wrap from one side of the screen to the other side before it is found to have hit the wall? It'll just keep on going. And I plan on solving that one by capping the overall speed that the ball can go in any direction. It's 11, so let's put it at 10. 12. No. This one. There we go. Okay. And for this, we will... Actually, you know what? Let's put it at the bottom so I don't have to do 2's complement math. Bottom, so this is going to be... no, this one. No, this one. D... B? And over here is going to be F4. Just calculate the next x coordinate, and if greater than the border, subtract instead. If close to the corner of our speed. There's always the DVD screensaver approach of arranging the starting condition such that it never hits the corner. That won't work here because I plan on being able to change the vector, the angle it's bouncing at, depending on where it hits the paddle, or where the paddle. Oh yeah, where it hits the paddle. Okay, and now we're gonna pause that real quick, and then we're going to change the ball speed, by let's say half a pixel each frame, right? So what is that? 3F? Okay. Then we're going to go ahead and make this bigger. 4x. And we're going to step frame by frame to see what happens. Oops. So this should hit that corner, both walls at the same time next frame. So let's see. Let's actually draw a breakpoint down there as well to check wall collide. There. So it hasn't collided yet. Actually, has it? No, it hasn't. It's gonna be next frame. Probably. Frame after. How many frames is it gonna... Okay. Going down, compare that to DC. Carry is not clear. Okay. So we're reversing it. 0 minus 0 is 0. 0 minus 3F is C1. Why do I reload it? How did this work before? How was this working before? How was that working before at all? It wasn't. We just thought, I guess, yeah. Let's just make the ball static and stick to the pedal. Need to ram the tiles of the pedal to break them. Yeah, that'd be a different kind of game, I think. So it was only changing the speed. Half the value for the speed. And I was going I was going at whole numbers before, so this is why it didn't break. Alright, that's why it didn't break. Thank you for that, I finally appreciate that. Ram out! Alright. Let's try this again. And I'm just gonna go ahead and turn off that breakpoint for now. Just to see what happens. This one will work fine, because I haven't changed anything. Well, I haven't changed the speed, rather. But let's put the speed at 3F. So this is half a pixel each frame. And let's go ahead and speed it up to half. So the visually moves the same speed, but I'm doubling the execution speed, so whatever. Alright. How's it bounce? I didn't put it in... Oh. Oh. Well, that was different. Excuse me? What? Excuse me? It just fell through the floor. What? And it goes faster when it does that, too. Because it's checking the first byte for negative. But if it's 0, technically that's positive, even though it doesn't have a value. Okay. Okay, so I need to check if the whole portion of the speed is 0, I need to check the fractional part of the speed for direction. We're gonna make a routine of that. Czechoslovakia. Get ball vertical direction. All right, load up. Ball speed y plus 1, branch on equal to fractional. Okay, if it's not equal to 0, that means we have a value in there. Branch plus to positive. Otherwise, it's negative. So we're just gonna jump negative. You know what? Let's do this. Hang on. So it would be possible that both of them are 0. In which case it wouldn't be moving at all. FXPT, how you doing? Welcome, welcome. YTXZ, how you doing? Looks like NES program Metrovania after all. Things fall faster when they clip the walls. Yeah, apparently. This could be worse. Imagine the ball could wall jump. Gee, it's debugging feature. Imagine if the ball could wall jump. Same as spinball. Here we come. Welcome. Do you know maths? I mean, I like to think I do. Okay, so this is going to be negative. So negative is going to be 0, right? And positive is going to be 1. We're going to do the same thing for the horizontal. Okay. So this is going to be JSR, what did I just call it? Get ball vert direction branch on something going down. Down is 1. Branch not equal to going down. And then we're going to do the same thing for the horizontal. Like that. Horizontal positive is 1. So if it's... Yes. Okay. So let's try this. Watch it... Wait, stop that. Watch it break again. If you do exclamation point tools, it'll drop links to them. I didn't do anything. Did I? I did, like, reassemble and reload this, didn't I? I thought I did. Thank you, Nutrition. Come on. Jay Victor, how you doing? Assembly is scary. I mean, it may look scary. Or at least 6502 may look scary, but it's not that bad. How is it? I want to check the horizontal at this point. Yeah, it's going to hit the horizontal. For a reason, it doesn't actually hit anything. Balance horizontal. Put a breakpoint there. Okay, it hits it. F. Store that into the speed. RTS. Okay, so it should have bounced horizontally. Oh, it's just changing the speed. It might be. But even then, it should at least... It should at least... I figure the carry would be, like an off by 1 for the speed, wouldn't it? Still going down. We're going right this time. We're still going right. Wait a minute. Why are we still going right? Hang on. Wait a minute. Wait. The speed was CF before. Hold up. The speed was CF, which is left. Why was it CF? Often intriguing semantics. The higher level languages have multiply and divide too. Well, I mean, that's just the architecture. I mean, because assembly on the SNES has multiply and divide, and depending on which mapper you're using on the NES, you can have multiply and divide too. Summer dude, how you doing? Welcome, welcome. Wait a minute, CF... Was it CF before? Because that doesn't... Hang on. Shouldn't like 3 and 2's complement be... So 3 in a positive 3 is a bunch of zeros and 2 1s. But in 2's complement, everything is essentially flipped, right? But that's -1. -2, right? -3 should be FC, not CF. Right? Or am I thinking of something? Am I doing that wrong? I wish you could actively look at the .NET runtime stack. Yeah, I've like accidentally dropped into like stepping through some .NET Assembly somehow, and I'm like, no, I don't want to do this. I'm trying to step to like comparing 2 strings. Why is it? Why do I do this? I can't figure out how to turn it off. Ogu Roma, how you doing? High-level languages use assembly routines for other architectures actually have multiply and divide. What's it? Instructions. D? FD is -3? Because this one here is... FF is -1. -2. Okay, yeah, -3. Whatever, I was up by 1. I was close. Regardless, you're doing it wrong. What is this? I mean, he's probably not wrong in this instance. I mean, it wasn't off by 1 here, sure, but all right. Well, let's see what happens, shall we? Let's keep stepping. It bounced again, whatever. Okay, 0 minus 0 is going to be 0, fine. Now this one, so currently it's 3F, and that should be negative whatever. It probably will be CF, actually. C1, whatever. Because what is actually 3F in decimal? Because I forgot it's half. 127 probably. Think about that file, by the way. Appreciate that. 63. 127 is the actual limit. Positive minus. Whatever. So could assume one could use NES architecture to assign for some kind of. They actually use the same processor, so absolutely. Their video and audio chips differ, but the assembly is the same. In fact, I can even use my assembler, CA65, to assemble Commodore stuff. There are some differences, like the NES rips out its decimal mode, but the Commodore has that, so they're mostly the same architecture underneath, though. It's the same processor. Zero-page I/O ports and the NES not having decimal mode. Yeah. Oops, I didn't need to. You know, I didn't mean to jump into that one. Okay, end of my happened. Going back up to the top. I didn't want to jump into that one either, but whatever. Yeah, minor details. Alright. Speed things. Update chords. I didn't want to jump into that one either. I do want to jump into the next one. Wall collide. Alright. Get the direction. We're probably going down. Yep, we're going down. Check horizontal. Alright. Get the direction. Load that up. It's equal, so we're going to fractional. Loading 3F. Hold up. Check horizontal. Get ball vertical direction. I need to check the right direction when I'm doing things. Gaining architecture familiarity for reverse engineering and the available compilers are crap. Nope. Okay. It still broke. It still broke. It bounced off screen though. It's bouncing. Okay. Let's see if it bounces correctly off screen, because that'd be kind of funny. It most certainly did accelerate. Why? The horizontal. It bounced on the horizontal though, off screen, which is funny and cool. Doing it again. It bounced twice. It bounced twice. I didn't commit yet, no. Probably because I know why. I know why. So if I'm moving too slow, or no, it doesn't matter. So when I move currently, it'll end up over there, right? So it ends up over there. Wait, but next frame should have moved it anyway. For whatever reason, it ends up past the wall for 2 frames, and then things just break. Yeah, find out how much we're better and go back. Yeah, that's what I think I'm gonna, because this isn't actually done yet. Like, I didn't write any of this in there yet. Yeah. So right, I mentioned it. Splitting the update coordinate and update sprite for the ball. Check wall collide, horizontal direction, sprite to tile, update ball coordinates here. So this is just going to move the ball. Then, hang on, I want that line too. Update ball sprite is going to actually update the sprite coordinates. So, up here, during the frame, update ball coordinates moves the ball JSR update. No. What? Hang on. Default sprite. Okay, so now in check collide, I can move the coordinates somewhere, and they will reflect in the sprite. Yeah. Direction. Okay, so let's start with the horizontal. So this changes the speed. That's all in well, but we're probably embedded into the wall. And for this, I don't think I need to worry about the fractional part at all. I think I just need to worry about the whole part. So let's take, what's it? You know what? Hang on. I can't do that here because this is for both directions, left and right. It works both in. It should work the same in both directions. However, the left and the right walls will be different when I'm moving the sprite. Right. If X is 30 pixels, I move it 3 pixels out instead. Right. Alright, so this one's going left. I'll come back to that one. Okay. So these two labels here are going to move the ball from within the wall to outside the wall, depending on how much it's embedded. Well, I need to apply. We'll get to why. We'll get to why eventually. So this is going to load up the wall right, and set the carry and subtract the X position +1. And this should have the amount it's embedded in, right? Why not? Because I said so. It never fails unless you run out of bits and positive X becomes negative X. I mean, just for I'll get to why. Don't worry. Okay, so then in A at this point, we have how much we're in the wall, right? Right, maybe. Oops, I don't want to do that. So I subtract it again, and that's that. I think that's right? Yeah. Yeah, we'll see. No, come on. I think this one's going to be a little different, because this one's going to be wall left. And it's going to go the other direction, isn't it? Load up wall left, and... No, for this one, I want to load up ball X +1. And then subtract wall left like that. So that gets how much we're embedded. Hold up. Wait a minute. Hang on. I'm missing this entirely. So what I want Vizion, how you doing? Do you also need to do reverse engineering? I messed with a few of assembly when I was playing with reverse engineering, doing some crack me challenges. That's mainly why I'm learning assembly, more or less, for in the context of NES games. Yeah, 10 to... Alright, fine, I will. So, Bridgewater and myself are working on figuring out how this little device works. It's a tape player, kinda, sorta, for a Famicom. So yeah, Bridgewater and myself are actually reverse engineering this little device to figure out exactly how it works. Admittedly, I haven't touched this in a while. But that is one of the goals for learning assembly on the NES, and the main goal why I'm learning assembly and not C, or rather why I'm writing assembly and not C. Sunday? Yeah, that's more recent than me. That's for sure. All right. Thank you for that file. Appreciate that. Alright, so on the collision frame, I want to take the wall coordinate, right, which I'll put as X. There it goes. Thank you for those files. Appreciate that. Or X1, I guess, or XW. And the X coordinate for the ball here, B. That Discord, yes. Remove the pinch roller so I could bring it with me next time I visit the... Oh, nice, okay. Oh, right, because it was a different size or something like that, right? Well, it wasn't the size you were expecting or something like that? Yeah. So currently what I'm doing... this one here, I am loading up X, and I am subtracting the wall. So, or, you know, let's just, can I? I didn't want to hit that button. I want to hit that button over there. Make that W, make this ball. No. Windows, come on, thank you. So that is ball minus W. So that should get me the difference, right? Right. So I need to take that difference and subtract it from the wall value. So the new X coordinate equals wall minus difference. Or X equals wall minus ball minus W. Right? Right. B minus 2D instead. But... But I need to figure that out first, right? D needs to be figured out. Jesus, Not that kind of wall, Bridgewater. But is my math correct there? Like, am I just a complete idiot, or let me write this a little bit more legibly. Right? So the x-coordinate is the wall minus the difference, and the difference is the ball minus the wall. Let's expand the brilliance. So this one takes the ball. Oh. I think that's correct. I think that's what that's doing. Right. And then the other direction for a difference over here would be so we got the wall, ball's coming that direction, but it's gonna be out here. That's the difference. Ball's out there. So this one, the difference is going to be wall minus the ball, right? And then I'm gonna take the wall and add the difference. That's gonna be x. For the other side, the left side, right? Right. Probably, I don't know. Maybe. So that makes that one. That's a B there, not a D. My handwriting is fantastic, isn't it? I've been trying to figure out how to do a reverse engineering stream on Twitch without violating the TOS. Thus far, the only angle I have is to reverse engineer open source stuff. That like loses some of the fun, though, doesn't it? Because, I mean, if you're having trouble, like, figuring out what a thing does or why it does it, like, it's open source, you just go find the source for it. And then it's like, oh, well, I guess I don't need to reverse engineer this then. No, see, so I can't if I want to stay on Twitch, you see, and I kind of want to stay on Twitch, doing a YouTube show. I think YouTube is actually a bit more strict on that kind of thing, honestly. Alright, so I'm gonna move this over here so I can type. Bounce horizontal left, bounce horizontal right. I had these backwards, didn't I? IRC stream. So left, I was actually that's the other wall. That's the right wall. So we're gonna load up. So we need to get the difference first. Get wall minus ball. Ball left, set carry, subtract carry, ball x, plus 1. That is true, though. Even though it's open source, is an effective way to check if you're right. I mean, yeah, that is true. It does. I still think it loses some of its, I don't know, allure if it's open source. It does make sense though, to like check your work, right? So there's fewer unknowns about that. I wish our binaries had the source code embedded for future reference. Wait, we have Python. Yeah. Until someone tries to obfuscate that so you can't read it. Alright, so at this point, this is an A.
And I just need to add that to the wall.
So clear carry, add carry, wall left, right? And store that back in ball X plus 1. I think. Beautiful plumage. This is an X parent. It's a good skit. Alright, so ball bouncing right. That's all wrong anyway. This is the one that I was doing the first equation. So I need the difference first. So that's loading up the ball X plus 1, setting the carry, subtracting wall right. And that's the difference. And I just need to subtract that difference from the wall. Right, right. Now I forget, like, my math rules. Hang on. No, I should be able to just minus this twice, shouldn't I? Right? Or am I not? I don't know. Let's see what happens. And we're going to comment out the vertical stuff because of reasons. Yeah. Okay, vertical is not going to do anything, but the horizontal should, in theory, bounce. Or shift a bit and subtract that. The combined math actually turns out to be the same for the left and right walls, except for having to deal with the left or the right side of the ball, assuming it's not a point. It actually will be a point. The collision I'm doing for the walls is point collision. It's not bounding box. So it is point collision. All right, let's see what this does. Not that one. This one. The problem is that my reverse engineer shortlist is cool versions of the NVIDIA 3D Vision Kit emitter firmware and creative audio codec. Oh, okay, that one didn't. Okay. Okay, well, we're gonna do that one and that one, and we are going to zero out the vertical speed if I can find it. Okay, we'll try that again. This is only moving in one direction, so we see it all. We should see it all the time. Mouse, how you doing? Welcome, welcome. Alright, let's see where this goes. So I have breakpoints on both of the collision code. It just sped up. And then it slowed down! Wait a minute. Yeah, the numbers are wrong. I know they're wrong. I think it did just teleport as well. Doing good, that's good to hear. Yeah, yeah, I'm pretty sure it teleported. Alright. Options, speed, quarter. Ball speed X is currently 3F. Fractional. It increases to C1. I know why. I know why. Again, I am checking. Or no, I'm... hang on. No, that... I don't remember what those numbers are off the top of my head. 63 to... I'm not sure what that actually is in decimal. Yes, that is C1. So what's happening is it's I think it's actually it's doing the math for the fractional bit, but it isn't doing the math for the whole bit, the whole byte rather. The whole number byte, because it's 0, right? So nothing really changes, but that that like changes where it's going, isn't it? If any of that makes any sense, I don't think it does. To 0 or not to 1 is the question. Yeah, basically. Where? Hang on, I forget where I am now. I am so lost. I've confused myself. I have confused the snot out of myself. So, like, is this part right? Should I not be setting the carry? What happens if I unset that? Or if I leave that alone? Where is my plus? I don't know. Oh, because I don't have this fully focused. And it sped up because it went to C1. Now, what should that actually be? That shouldn't be C1. That should be something else, shouldn't it? It should be FFC1, right? The speed is signed. Yes. Yes. Correct. The speed is signed, but the position is not. Correct. So I'm actually doing this backwards. Hang on. Should I be doing it that way? Nope. Okay. Okay, so F8 with this window focused is save state. F8 with this window focused is frame step. Oh, lovely. Okay. How about there? Oh, right, because I'm at like half speed or something stupid, aren't I? Well, no, that shouldn't... Normal speed. 1, 2, 3. 1, 2, 3, 4. What is it doing over here? Hold up. Wait a minute. Why is it over there now? Position goes from F4 to 0B. This one? So it is this is broken. It is this code that's broken over here. Let's drop a breakpoint there to see what it's actually doing there. So bounce horizontal left and right. 2 breakpoints. Continue onwards until one of those hit. Because one of those will hit. Let's see what the code actually does. Okay. Bounce right. Okay. We're on the right side. We're bouncing on the right side. That's good. Yep, skip the wall and carry on normally. Should you subtract a fixed distance from the position? So, not necessarily. Wall right is like the across the screen. Wall right is this wall over here. Alright, so we're loading up the ball position, F5. That's actually F5-3F. At least it should be. No, it's straight up just F5, because I guess we're lined up directly with the wall at this point. Because we're moving at half a pixel per frame, so we will line up exactly. So okay, that's fine. Set the carry. Subtract F5, which is the wall. That's the distance. That's the difference. I need to reload the wall and subtract that value. So it's a high value subtracting, it'll pull the ball across the screen. Yeah, something like that. Okay. I think my breakpoints are broken, but whatever. Oh, that one's right. Okay. Oh, because the changes happen below it, right? Right, yeah. Yeah, the delta value. Alright, so loading up the wall, setting the carry, subtracting the wall. Well, loading up the ball, which is the same value as the wall, whatever. Store that into tempx. The difference is 0. Load up. Subtract the difference and store it back in F5. Right, this? Right. So this position doesn't change this time, this frame. Because we are exactly on the wall. But the speed does. There we go. Okay. When using a... hang on, let me... I'll read that in just a second. You can't see that. Let me see what happens when it hits the other wall. Give me a sec. Oh, I think this is wrong, too. Maybe not. Hang on. Oh my goodness! Holy crap! When using assembly, and you use an opcode like subtract, does it subtract the input you gave it from the previous address you've accessed, or does it pull from a register? If it pulls from a register, how do you know which registers it's going to pull from, and how do you select the register you're going to pull from? Ah, so this is the 6502. There are a total of 3 registers. Yeah, it does depend on the architecture, but this one here, there's only three registers: an accumulator, an X register, an index register, and a Y index register. All of your math, all of it, happens on the A register. X and Y are only used for indexing modes. You can't do math directly to values in those registers, aside from decrementing by 1 and incrementing by 1. Everything else is on A, and either an immediate value or a memory location. So, you know, I'll bring up the add carry operand. So these are all the addressing modes of the add instruction. In all of them, add memory to the accumulator or A, the A register. So in a sense, it'll just put whatever you put in register A last. Put whatever you put in. Yes. So it takes whatever's in A and adds the memory location, either an immediate value or an actual address somewhere, and adds the carry to it, and then it stores it back in A. And it will also affect the carry depending on the result of that addition. And it's the same exact thing with the subtraction in relation to which registers it touches. Okay, so I've got bouncing left and right actually working. This is... You know what, I'm gonna let it get to about there. And let's see what happens when I increase the speed to 2.5 pixels per frame. Let's see what happens. Yeah, back in that direction too. Actually, it's more than 2.5. It's 2 and a bunch. Let me make it 2.5. Actually, 2.5. 3F. Okay, so now it's 2.5 pixels per frame. See what's this program manual at the top? There's always a manual for the store stuff. Yeah. Just rinse and repeat for Y. In theory, yes, but I want to make sure that this one's actually correct first. And I do want to put these breakpoints back, and I don't know what those are pointing to anymore, so I'm going to get rid of them. I don't need the map decoding stuff either. Okay, those breakpoints. Alright. Okay, it bounced. Did it seriously just bounce directly on the wall again? Hang on, what is the wall value? I was really hoping it wouldn't. It bounced exactly on the wall again. Really? Really? Okay, I guess. I mean, there's a good chance this will screw up as well, but... Alright. It's the other side. 0A, it bounced... No. That's the... It did. It bounced exactly on the wall again, because of course it did. So let's go ahead and change that to 3 pixels per frame. The screen isn't an even number of pixels, so it's not gonna... Yeah. Okay. F7. There we go. That is not F5. Beautiful. All right. So loading up that, subtracting F5. So next frame should be 2 pixels off the wall. I'm gonna set the speed down to 1/4. Like that. When making a game like this, you're essentially basing your speed and FPS off the speed of the 6502, or can you cheat FPS? No, that's alright. Yeah, so the frames a sec. So I'm trying to think of a good way to explain this. So on the NES, there are 2 main chips. There's the CPU, which are all these instructions. The one you can actually program, and then there's the PPU, the one that draws the screen. That PPU on a NTSC and NES anyway, it draws the screen once every 60 seconds. No. It draws a screen at 60 FPS or 60 Hertz. Period. No matter what you're doing anywhere else, it draws that screen. Even if you're not ready for it at all, when it does draw that screen, or when it's finished, rather, it's in the vertical blank period. The original, well, when it was the big CRT tubes, it's when the beam was actually going back to the top of the screen. Once per 60 seconds. Yeah. Okay. Yeah. Anyway, so in that time, or at the beginning of that time frame, the vertical blank period, it sends a signal to the CPU. Says, "Hey, I just finished drawing a frame. Just thought you should know." And the CPU handles the interrupt, that NMI, and it's up to you to change things during that frame, right? It's up to you to actually do all your updates. So games run at 60 FPS, but that doesn't necessarily mean that the engine of the game runs at 60 FPS, because you can skip a frame and just draw the same thing next time, so long as you don't touch video memory. Yeah. Yeah, whether the graphics update 60 frames is another story. Right, so, like I said before, the PPU will draw the screen whether you're ready for it or not. So if you're still doing updates, the PPU doesn't care. It's going to still draw to the screen. That can come with some interesting side effects, where you think you're writing at address A, but you're really writing at address D, because the PPU hijacked the address on you and is doing its own thing, drawing the screen, and you're interrupting that. Hey, just finished your time to shine, grabbing a snack for a split second. All right, let me update. Exactly. Yeah, it's kind of like that. Yeah. Actually, I've got a. So this right here is the event viewer. This shows exactly when things happen on the screen. So the 2 numbers you see next to my cursor are the scan line, which is the smaller number right now, the second number, and the cycle on that scan line. I believe that's CPU cycles on the scan line, I think. I could be wrong on that. I think it's CPU cycles on the scan line. Yeah. So down here is where the NMI actually hits. It's actually right there. Cycle number 25 on Skyline 241. Then right after that, I can start writing to the PPU and changing video memory, right? So these horizontal, or these slashes essentially, are writing the sprites to the PPU. Then I'm doing a few other things, and then it'll wrap around and continue onward. What kind of clever artifacts have you had from carefully timed mid-screen reads? Mid-screen reads? I don't know. Does the PPU have its own stack you write to it? It has its own dedicated memory. In fact, these writing the sprites, that's taking a chunk of CPU space RAM. In my case, it is this chunk right here, these 256 bytes, and it's sending it to the PPU over a serial line. And it's writing that to, what address is that actually? I don't remember what the address on the PPU is. Registers. Come on. I am data, address. Where is that actually in the PPU space? I don't. So this isn't something that I usually need to keep track of. Is it towards the end? Maybe. I don't know. Like, this is a name table space. It's not a serial line, but it is sending a byte at a time. Close enough. Yeah, the PPU is a state machine. It doesn't use a stack. Exactly. Yes. So the PPU is not something you can program at all. It's just something you can interact with. But as a fixed display program as such. Yeah. Yeah. So you modify its memory, and you interact with that memory over a communication channel. And it just takes that memory and draws it to the screen. Essentially, that's basically all it does, is take the memory and draw it to the screen. There are some weird things you can do, though, like when you interrupt the PPU. Oh, it's separate here. It's its own memory space. Yeah, there are some things you can do when you interrupt the PPU during the draw. Most commonly, it's scrolling. So if I actually open up my last game that I did here, so this one right here. So this game I wrote on stream. Hang on, was that music out? Okay, no, the music was actually correct. Oops, I turned my keyboard off. I wanted to play. So this is something I wrote on stream since like October till like a month or two ago. Yeah, 3/4 of a year. Yeah, most of the year. I didn't actually mute this. Audio. Do not enable audio, thank you. So this game is basically a T-Rex runner game. If you've ever opened up Chrome without internet and got the little T-Rex runner game, that's basically what this is, but on the NES. Anyway, you see that there's two separate or three separate scrolling planes. There's a skyline in the background, which is moving kind of slowly. There's the foreground, which is the play area, which is moving at a decent speed, and then there's the bottom, the score and the level seed that are not moving at all. Now normally, if you don't, I never fixed that bug. Hold it. What? Wait a minute. Huh? What is this? What is this? I love finding bugs for something that I finished a month ago. Anyway, my point is, normally the PPU will just want to draw one screen as it sees it. If you don't interrupt anything. Scroll overlay. That's this scroll overlay here. BNWL, how you doing? For the Daily Towers. You're interrupting the PPU and giving it updated commands in order to give the PPU 2 different speed and data. Kinda, sorta. So I'll explain what's going on here. So, data scan line. There it goes. So this box right here represents where on the screen, or where in memory it's drawing the screen from, right? Where it's reading the screen data to draw. So this is the skyline scroll, right? Now I've got a sprite. This guy. He's like in the middle of the screen, kind of over there in the purple area, right? That's sprite 0. That's the first sprite. When that sprite is drawn, and when it's drawn colliding with a non-transparent background tile, it sets a flag on the PPU. And that's something I can check for over and over and over again, right? So if I come over here and turn that one on, so these orange dots over here, that's me checking for that flag to be set. And then right over here, it happens. Right here actually. Sprite 0 flag is hit, and at that point I can go ahead and start doing my own thing, right? So right after that's hit, right over here, I update the scroll of the PPU. Say, hey, by the way, you're no longer scrolled over to over here. You're no longer however far in you are. Instead, I want you over there. And the PPU doesn't question anything. It just goes along with it. So that's the scroll for the playfield, right? And then I just sit in a wait loop, a bunch of nops, no operations in a loop for I don't know, a bunch of time. So that's some timing code, so I can wait until the PPU has drawn the playfield, and then after that I go, okay, you know what? I changed my mind again, PPU. I don't really want to like draw there. Let's draw the very beginning. Actually, let's just draw this one spot, always in the same spot of the screen. So I changed the scroll again down here, just to move it all the way back to the beginning. I also do some other stuff here, like changing where it's reading the tile data for the background. But I mean that's a similar idea. It's I am changing the state mid draw, and the PPU doesn't ask any questions. It just goes with it. CPU waits for the NMI from the PPU. Not really. It's an interrupt. The program waits for the NMI. The CPU is interrupted. It's a non-maskable interrupt. So it's the CPU is interrupted by the PPU. Said, hey, by the way, I don't care what you were doing at all. VBlank is starting. Get your crap together and let's go. So it's an indecisive girlfriend with her boyfriend, something like that, yeah. But yeah, so the CPU cannot choose to ignore the NMI. It's a non-maskable interrupt, right? So it can't ignore it. What's the maskable? It's one that can be ignored. Bridgewater is going to correct me if I'm wrong, I'm sure. But IRQ is a maskable one. That's one where it's like, all right, I choose, I choose to listen to this interrupt, or you don't, right? Yeah. Yes, IRQ can be masked at the CPU level, right? So the NMI is like bullhorn screaming at you, right? But the IRQ is like, you know, unplugging a phone line. The phone's not gonna ring now, you know. But you can choose to, oh, I want to hear whenever this happens, so you plug the phone line back in or something, you know. Remember IRQL from Windows Internal 7, like IRQR levels. Yeah, so there's only like 3 interrupts on the NES. The reset, which happens when I hit the button on the front, that's the reset, or when it powers on, it uses that vector, that interrupt vector, that address. There's the NMI, which is the vertical blank thing, and then there's the IRQ, which, excuse me, is pretty versatile actually. Some of the audio engine uses it, or the audio hardware uses it, and mappers can also trigger an IRQ interrupt for things like scan line counting and whatnot. It's rather rare for a hardware interrupt to not be maskable at some level. On the NES, for example, you can mask NMI by disabling it on the PPU. That is true. That is true. But on as far as the CPU is concerned, it can't be turned off. The PPU can be set to never send it, yes. But I mean, if it were sent by some other means, the CPU would still receive it. Just 31. Yeah, there's a whole 3 on the NES, and one of them isn't used in normal operation. You should compile a pile code from GitHub. That's I've seen it. I've started the repo. It's actually an interesting read through. That's a different architecture entirely. That's something completely different than 6502. But I think that the NES might be more powerful than that, actually. I forget the exact specs of the computers on all that hardware, but 6502 has software interrupts as well. Break. I mean, yes. Ironically, the reset interrupt can be masked on the NES. Really? But doing some mass, everything in the CPU is powered down. Wait, what do you mean by everything? Do your games reside within the space on a NES cart, or do you go outside the bounds? So, no. That's like a memory mapping question. So this code all has to exist in a 16-bit address space. It has to exist somewhere that the CPU can see it, between hexadecimal 000 and hexadecimal FFFF. It has to sit in there somewhere. That's 32 kilobytes of memory. So all of the early games, all of the launch titles on the NES fit into that address space, into the 32K of program ROM plus 8K of pattern tables of character ROM. But that actually isn't CPU space. So I'm ignoring that for now. Later on, though, people figured out how to add more memory to that, and that's just basically okay. So while the CPU is looking over here, doing instructions over here, we're going to take this address space that the CPU isn't looking at right now, and we're going to change it to look at a different part of the chip on the cartridge. That's memory mapping. I mean, reset edges are sampled under control of the 6502 PLA, just the NY edges and RIQ levels. Just like the... Oh, see if there's a jam instruction. See if it gets wedged such that it doesn't check any interrupts anymore, nor does it fetch instructions. So it just locks itself up. Yeah, true enough. Yeah. Not so much back then, but you can make a custom cart that would read from an address space from a PC rather than memory in the cart. I mean, kind of, but that connection would not be fast enough, actually. The latency would be too high. That said, though, that wasn't the switch I wanted to do. I don't know if you even saw that, but I turned off one of my lights accidentally. Now I know this cart says Barbie on it. Trust me, it's not a Barbie game. This guy right here is actually a ROM card. So it's an SD card. That's stuck on a board in here. Basically, what that does is it reads the you know, power it up. Give me a second. It reads the that SD card, and you select a game, right? You select the ROM, and then when you select the ROM, it loads into some SRAM chips or some RAM chips on the cartridge board, and then it loads the game from there. So this right here is my real hardware off screen. There it is. I need the correct controller, however. So these are actual files on that SD card. And these are all ones I've written. And this is that same runner game, but on real hardware now. So it read it off the SD card, and it dropped it onto its internal RAM, essentially on the cartridge, and is playing it from there. If you wrote an emulator, you probably could. Even overkill that would read it. Don't idea, but we're using a fiber hard disk setup in the car. That reads input from a setup is the. So it's not exactly the latency in the wire that's doing it. It's the latency in the response from the hardware. So this is a video on YouTube about this guy that essentially feeds data through the NES's PPU to display it through the thing. So what he was doing, he was looking for when the PPU read data off the cartridge, and instead of giving it the data at whatever address it asked for, he just spat out whatever data he wanted on the screen, essentially, right? So at first he was reading every single address, right? So he read an address, interpreted that address, and then spat back something else, essentially, right? But that was far too slow, even on like an Arduino, a Raspberry Pi. The latency was far too high on that one. Yeah, because you need it like what, nanoseconds, I think. Is it a nanosecond thing? I don't know. It might be. I think it is. But yeah, so you need like a really fast response time. And he ended up getting around that by only looking for the first address it wrote, the PPU wrote, and then ignoring everything else from the PPU and just blasting it with data. Here's the thing about destructive. Here's the thing about that description of memory mapping. CPU isn't looking for a brief period every cycle. You can swap memory bank out from under the exist. Yeah, you can, absolutely. You can pick a new bank. It's not. Actually, yeah. So that. Yeah, there are mappers that map the entire address space at the same time. 300 nanoseconds to response. Yeah. Basically, the NSTA to the mapper does the write in the last cycle of the instruction, fetching the opcode for the first cycle of the next instruction can happen in the new bank. Exactly. You have about 300 nanoseconds of response time for full participation on the CPU bus, considerably less for the PPU bus. Yeah. Yeah. Yeah, so he was actually hitting that limit where he wasn't going fast enough. He couldn't keep up with the PPU speed. So he you know, predicted what the PPU would want. He didn't care what it wanted. He just sent everything in the order that the PPU wanted it in. Because it's all very deterministic for the PPU. Like it's going to do the same thing every frame, essentially. It's going to ask for the same stuff every frame. Yeah. So you don't need to know like what address the PPU is asking for. You just need to send it some data, because it'll always be the same address at the same offset of time from the beginning of the frame. Yeah. Anyway, I got sidetracked there. I got a little sidetracked. Let's open this guy back up again. What broke? I forget. Well, thank you. Appreciate that. Did this, like... Okay, that does, like, work, I guess, right? Oh, hang on, let me change that speed again to like 3. Or okay. I know you might not be able to see this very well, but give me a second. No. Fractional. And whole. Where is my... There it is. Okay. Oh. Is that actually working? Hold up. Hold the phone. That's actually working. Wow. Alright, cool. Let's just call it Pong. Can I post a yeah, yeah, sure. Yeah. I missed a little bit of chat. Hang on. Yeah, now I need Y. I need Y. I think the most realistic approach is to have multiple banks in the cart and update one bank from the PC while another bank is in use. Only afterwards swap banks. See, that wouldn't necessarily work that well, I don't think. Because there are instances where you swap banks multiple times per frame. Yeah. Like, for instance, you have your engine code in one bank. Let's the way I have it split up here, on this game. So I have the memory split up, the CPU memory split up into two portions. There's a swappable bank and there's a fixed bank. In the fixed bank, it has a bunch of common code, right? So it's got the default NMI handler. It's got all of the mapper setup stuff. It's got the reset vector. It's got some like common functions, like waiting for NMI is one of them. It's got all the mapper stuff. And then in the first page, I've got a bunch of, or the first half of it, I have a bunch of swappable pages, right? So during a frame, I would be running the code over here, right? And then once the NMI hit, right, the code jumps down to the fixed page into NMI, presumably. And after that happens, right? Like, say for instance, I want to play some music. Well, the music is going to be stored in, say, page 02. So I would swap out this bank right after I'm done drawing things and all that. So at this point, the screen is probably starting to draw now. So I'm on bank 02. I read up the music values. I play the music engine for a little bit. And then I'm done with that. So I go back to what I was doing, right? So I jump over here to swap the bank. select the page, and then that swaps out the audio stuff, the audio data with the game code again, and continues on for that frame, right? So yeah, and if I want to do like an animated animated graphics with paged CHR banks, I could do that as well. Not with this mapper specifically, but actually with this mapper, but now with my configuration, where I would switch between the banks depending on which frame of the animation I'm in. A lot of games actually do that, and some mappers even split up the banks such that it spans like four rows in the pattern table. So you can swap out like 4 rows and animate 4 rows of tiles. So that's like what, 64 tiles per frame, which normally you wouldn't be able to do without that, right? Yeah. If you're working 16 megahertz MCU and 1 cycle per instruction, you have 5 instructions to handle CPU bus operation. You 1 cycle to detect your start edge, 2 cycles to turn the bus around so that you can output a byte, 2 cycles to write your output data, and then you don't have any time to figure out what to write in the bus or check it. Yeah. So it's timing is a difficult beast. Yeah, so that still wouldn't be fast enough, because the link here, that fiber optic link, isn't the bottleneck. The bottleneck is your computer responding in time. So your computer deciding what to send. That's the bottleneck. Yeah. So that link can be however long. Doesn't matter. It can be like a centimeter long or 6 feet long. Doesn't really matter all that much. What does matter, well, I mean, it will once you get long enough, but that's besides the point. Yeah, what does matter is the PC, the computer, responding fast enough to get the memory there. I should rerun those calculations, presuming write only. You do that. There are instances where you swap banks multiple times per scan line. I could, yeah, I wouldn't be surprised actually. Yeah. But notice I didn't say the card only had 2 banks. I might need to have quite a few for this to work, and/or might need this second layer of memory banking. Yeah. So there really isn't like a limit, I guess, to how many banks the cart can have. I guess the limit to that is how expensive you're willing to make the cart. Like for instance, and how you want to set it all up, right? I mean, and how you want to wire it all together, and how you want to expose the API for swapping banks and all that. PC sending live data to the CPU directly with no NES RAM will be in the middle of self-modifying code. Could you add memory to an S card? Not to an existing one easily. At least not without the proper mapper on the cartridge and a steady hand for soldering. So let's go over here. Let's hit a random game. What mapper is this? Whichever one. Okay. So this is, I don't know, some random game, but it's actually the same mapper that I'm using, MMC1. So there's 3 chips on this guy. There's the 2 memory chips, and then there's the mapper chip over there. This guy right here. This guy controls which portion of these 2 chips are exposed on the data lines. And the, well, address lines too, technically, but... So if you were to add memory to this, well, 2 things would need to be accounted for. Number one is the program expecting that data to be there, right? And number two is that mapper being able to address that much memory. So these mappers have different ranges, different capacities, rather. So the mapper I'm using, MMC1, or Mapper01, has a maximum ROM capacity of 256K. If you're using the 16 swappable and 16 fixed, or 512K if you're using the fixed 32 kilobytes. Custom opcode, not really custom opcode. It's more of, well, not quite. It's sending data to registers on the mapper cartridge, and you do that by writing to program ROM space. Like for instance, for the MMC1, to set everything up, well, to do anything really, I load up a value and I store that value into ROM space. Thank you for the follow. Appreciate that. So the hexadecimal A1000 is in ROM space. That's not RAM. That's not writable. That's read-only memory. But I'm writing to it, right? Why would you be writing to that read-only memory? Because the mapper is monitoring these address lines. So when you're writing data to these address lines, the mapper is picking up on it. And I'm shifting it here because the mapper is only reading the last bit every write, to make the chip a little bit cheaper and to save on electronics and all that. So I think it's like 5. What is it? 1, 2, 3, 4, 5. Yeah, so it only reads like 5 bits of the value you're putting in there, right? Yeah, you can only have a certain number of pages for that, right? Yeah, because you only fit a certain number of values into 5 bits. You know, oh, just 32, only 32 pages. Yeah. You could design a new card technically, and add like 64-bit bank addresses. I mean, you could. It'd take forever to swap those banks, but yeah. And by forever, I mean you'd have like a bunch. Actually, it wouldn't. It would actually be about the same amount of time as this, wouldn't it? Or more or less. I don't know. It'd still take multiple instructions to change a bank. There are other mappers though that are just a load value and then store into an address like this, and it does everything you need to do right then and there. Those are some of the later mappers. But this being an earlier one, they wanted to cut costs a bit, or keep the cost down rather. But if I have a look at MMC3, I think this one is right. MMC5, I was close. Yeah, I think you just write data to given addresses, and it does that thing. So 5001, you just write data to that address, and it just does it on one write. 16 bits would be enough. 65,536 banks. It's a lot of banks. Yeah, it's a lot of banks. But then again, how are you dividing up those banks? Are those 32K banks, or are they like 8K or 1K or something like that? If banks were 16K, it would give you 1 gigabyte of memory. Yeah, that's yeah, okay. It's not bad. Has there been an original NES card that has been that has expanded memory for a bigger game, assuming the price of the card would increase to the engine? Not like aftermarket expanded. They have mappers in them, which is what I'm using here to expand the memory on it. So yeah, that's what a mapper does, is it expands the memory essentially. And this is just 256 mappers right here. There's more than this, right? There's variations of these guys and all that kind of stuff. So, modifying your existing cart is tricky, but if you're making your own cart, you can put as much memory as you can afford. Yeah, exactly. Based on their electronics mapping schemes. As an example, you could reverse the last 8 bytes of memory. Yeah, so. Yeah, but if you expand the memory of an existing game, it doesn't do anything at all because the game doesn't expect it there. The code does not expect that memory there. So even if it is there, it doesn't know to write to it or to use it. You know, so it's not like you could do anything different to it. Yeah. So expanding memory of an existing cart accomplishes nothing really. Because it's not a dynamic system. It's not a system that expects to have memory added to it dynamically. It's not a system that allocates memory dynamically. It's all a very static system. So you could have infinite memory. I mean, kind of, sort of. I mean, it has big memory than the standard, so really made up values. But let's say a standard cart, most companies had, if I don't know or something again, has a company that made a cart for NES is upwards of 512. Let's say, I mean, yeah, that's essentially what the multi-carts are. They're just a bunch of memory packed into a cartridge with a special mapper chip, and you have a list of games that you select from, and then you select the game, and it swaps to that game's bank, and it goes from there. So yeah, like, you know, the Chinese knockoff multi-carts are basically that. Yeah. But yeah, it all depends on your budget and the mapper scheme you've got, and you know, all that kind of stuff. 64-bit bank address and 16K banks will give a lot of terabytes. I'm not even going to try reading that number. Yeah, that's a lot of animation data. 274 billion. With that, I'm pretty sure you could like encode video in the NES's format in some way, like as character data, and then just like swap the character bank, like, I don't know, every few scan lines to get a new bank. Can you modify a multi-cart to be like the SD NES cart? Yeah, I mean, not practically, because there's a lot more hardware on the EverDrive. That's the ROM card that I've got, that handles reading the SD card and writing those values to the RAM and all that kind of stuff. NES Data Center. I mean, in all honesty, like, the sky is the limit if you can figure out the electronics for it. It's just the constraint of getting data getting data into view for the CPU when you need it. AWNES, Amazon Web NES. It'll speed 300 bits per second. Yeah. Your horizontal color resolution would suck, and your total color depth would suck, but you can swap out banks fast enough for 240p video. Yeah. Yeah. Anyway, let's see if I can get bouncing on the vertical working now. Okay, so people are still using fireworks. They're in that direction. That direction. Can you hear those? It's not gonna happen again. Did you hear that? The mic is picking those up. That's amazing. I love it. Having a 52 baud modem. Mainly having to swap out those banks yourself a second. Yeah. Who needs Netflix? Just do NES cards. They Netflix? At one point, Nintendo tried something like that, but with the Game Boy Color, I think, right? The TV shows on a NES cartridge, or on a Game Boy Color cartridge. There's only like a few of them, and like there's like a few movies I think that were severely edited down. It was Game Boy Advance, but yeah, it was edited down, and I think for length, and horribly bit starved for color and resolution. So the video looks like absolute trash, but it's a thing, and it exists because of course it does. Sony tried it as well with UMD videos. Well, those are on discs though, weren't they? So that one at least like was with the Vita, yeah? Or not? Was that the first Sony handheld? Yeah, but still sucked. All right, well, all right. One's trash, one's treasure. I mean, what's the saying? Like one person's trash is another person's treasure. PSP. Yeah, there. Thank you. PSP. That's the one. Actually watchable too. Yeah. So again, there's videos of the Game Boy Advance stuff on YouTube. Oh, just Apple. Really? I don't think I've seen that one. All right. So let's see if we can get this bouncing on the vertical as well. So let's go all the way down to somewhere. Yeah, easy. Where am I actually looking here? Line 400 something. Okay. So that's the horizontal code there. Oh, you know, let's get rid of that, because that works. Okay. Check bounce vertical. Oh, so I need to split this into two of them. Vert top. And then this one's going to be bounce, vert, bottom. Right? I don't know. Yeah. Program prefix. But if you want to size optimize the code, the new X position of the bounce works out to be 1 plus 1 minus 1. The other distance the code will be the X value for the wall, given the bottom line. I just want to get it working first, and then I'll figure out optimization if I need to. Why? Because I say so. PSP 1001, I had one missed. Other versions of the PSP, then Vita, then Go. On the other hand, line take knows that, yeah. Yeah. Never invent your own math. Doesn't compute on 6502. Alright, balance. If I, you know, it helps if I spell things right, you know? So this one I don't actually need to, I don't need to have that there, but I'm gonna have the label there anyway, because whatever. Step 1, make it work. Step 2, make it right. Yeah. Step 3, optional, make it fast. Step 4, profit. Want to see it fail and fast. No time to optimize. Alright, was this actually correct? It was almost correct. I needed to swap that, right? I needed to swap the order of that. Let's remove that. And I do the math on the fractional part first, and then the whole part using, and bringing over the carry. Okay. Alright. So, bounce vertical top, that's going to be the same as the bounce left. Load up, wall, top, set the carry, subtract carry ball Y plus 1, clear carry, add carry, wall, top, store that in ball Y plus 1, then jump to bounce vert, which is right there. Yeah, okay. This is going to be loading up ball Y plus 1, setting the carry, subtract. I see that you're saying things. Give me a second. Subtracting wall bottom, storing that into temp X. I know it's X and not Y, whatever, or the other way around, whatever. Loading up the wall bottom, subtracting temp X, and storing that back into ball Y plus 1. Okay. Zandy Geeks Out, how you doing? Welcome. Welcome, welcome. Evening also, I did from Linux went bye-bye, and I'm back on Windows. Oh no! Bright side, I can easily learn to go on Windows. Alright, I mean, you know, silver lining all that. But how you doing? Welcome. Finally learned using Go, using a wooden... Never the wrong Go, wow. I should never name anything the same that they already... The same name that already exists. I mean... It's just a temporary variable that I'm only using in this one spot here. So, whatever. Thank you for that file, I appreciate that. I've tried a little long time ago, never really got any... Oh, the game, yeah. The world run out of names by 2036 or so. Would it though? Okay, so let's go over here and then grab this. And swap these. So now, excuse me, it's going to be moving only vertically. I'm gonna be surprised if this works first try. Okay, let's turn off these breakpoints because they're not correct anymore. Oh, I love it. Oh, it's beautiful. It's beautiful. That's fantastic. Let's add some horizontal speed to that. What? Hold up! Wait a minute! What was that? It was in the corner somewhere. Like, that corner over there. I mean, it kind of works. That one might have actually hit right in the corner. I'm speeding. You know, hang on. Let me turn on the. Where is it? Options input. Was it? No. Ah, here it goes. There we go. I got the display on the corner there, so you can see the buttons I'm pressing, even though, like. Okay, so we're moving at a significant speed here. Okay, 3 pixels per. No, 5 pixels per frame in the X direction. The answer's no. Yes and no. Yeah, even on the corners it works. Apparently, it didn't work like once. I don't know why. It's just it was that corner right there. I guess it was a special angle or something like that. I don't know. I prefer plaid. Yes, this is a Super Nintendo controller. This is a first-party Super Nintendo controller, actually, that I'm using for all my emulator goodness. I've got a adapter back there that I'm not going to dig out, but it's a SNES to USB adapter. So this isn't some sort of knockoff. This is actually a first-party Nintendo controller. I mean, yeah, I guess if the ball speed is over like 10 pixels per frame. Or, yeah, about 10 pixels per frame. But, I mean, so far it's working fairly well. It's at, like, 6.5-ish. Where is this guy? Six, 7. It's a little faster now. Okay. Okay, so it is exactly 7 pixels per frame. What happens if it's at 8? Let's change. Whoops. Okay, only horizontal for now. All right, what happens if you go 9? Okay. 10? Really? 11? 12. Wow! Look at that. That's... Oh, I think it warped once. It's starting to warp at 12. Okay. Try 64. That would warp around entirely. Yeah, it's starting to warp around a little bit. I'm holding up and it bounces off, so then it reverses. I'm still holding up. Yeah, so it is warping every once in a while because it's hitting it just right, where it wraps around the walls. So those walls are like 10 each, 10 pixels each, I think. Yeah, so if it wraps around in one direction, if it goes, if the frame before the collision, it is within 2 pixels of the wall. By the next frame, it will be on the other side of the screen, which is what happens there. And it only checks the wall in that one direction. But if I change that to B, I don't think that'll happen anymore, will it? It might. It's not as often, I don't think. But yeah, so if I make that like a max of like 8 pixels per frame, in like either direction actually. So let's Like, that's the fastest it will go, right? Is this even... This is normal speed, okay. Yeah, so I figure I will have an upper limit to the speed. It won't be this fast, I don't think. It might be, like 2, maybe 3 pixels per frame. Because the paddle can only move so fast, right? I might have some, like, some power-up drops that speed up the ball to, like, this speed, maybe, just to screw you over. Or power down, as it were. I don't know, like a poison pellet or something like that. But it's good to know the upper limit of this. It's good to know the upper limit. So let's go ahead and commit this before I break it. Yeah. Run this on hardware. If you give me a second to commit, I will, actually. Yeah. As otherwise, it can warp if it happens exactly to touch the wall. One frame and the next frame is... Yeah, so that's what was happening when I had the speed set to 12. It was too close to the wall. I know you can't see it. It was too close to the wall the frame before, so on the next frame, it wrapped around. It warped to the other side of the wall, essentially, and in doing so, it wraps around, right? It went below 0. So if the x-coordinate was less than 12 and the speed was 12 or above, right? It was 12. There's 2 pixels that there's a 2-pixel window where on the next frame you would be past. You would wrap around to 0 without touching anywhere between 0 and 10. Check the first collision again on X. What do you mean? Oh, I see. Okay, yeah, I see what you mean. Let's over here. Okay, so they're both. It's gonna be moving both directions at the same speed. Alright, looks like it's working. It might have been something weird I was doing, I don't know. Anyway, I'm gonna commit this. Something with the memory edit, probably. It probably was. Because I was timing the memory edit to be changing values that I was expecting. Oh, right, that one actually did change, yeah. Okay, so let's make sure that I have everything in here that I want in here. I want to move this to the top. Give me a second, I'll move that to the top, though. Come on. This stuff, these constants I want at the top. And mainly what I'm looking for here is code that's been commented out that I forgot to remove. That's essentially what I'm looking for. Oh, right, because I changed the size of the sprite. Right. What is that, 300? Oh, no, it's different parts of code. Alright, that one, and... What was my last commit? Oh, yeah, whatever. I'll add that in a separate thing. I mean, I'll add that, sure, why not? Not a big exhibit, yeah. The ball's moving, perfecting in a sine wave. In mine? I mean, yeah. Yeah. The capabilities of WebAssembly. I actually have a project that uses WebAssembly. It is a video streaming thing. Patterns aside, it touches each corner perfectly. Well, it depending on the speed values, it doesn't touch the corners perfectly, but yeah, or it depends on the sample rate, but yeah. One quarter, 37 bosses. Yeah. Alright, so make the ball bounce off the walls. Sounds like Mega Man. Alright, so bounce the ball off the walls using a single central collision point on the ball and a bounding box for the walls. Triangle wave. Oh, yeah, so it would be... Yeah, it would be a triangle wave, I think, wouldn't it? Yes, it would be triangle because it does not slow down during the edges. It immediately changes course on the edges. I don't take song requests, actually, mainly because I don't want my VODs to be muted. So I actually use a service specifically for music, because like if someone's watching a VOD and like it's muted, why bother or continue watching, right? So I have all my VODs up on YouTube. Yes, I do use Pretzel. Yep. And I actually pay for the service specifically so my VODs do not get muted. Let's try this angle. He also uses bagels. I actually haven't bought bagels in a while. I need to do that. I've been looking for that one flavor of bagel that I like just like the cinnamon flavor, because I hate raisins in bagels. Or no, it was like a French toast bagel or something like that. And I don't know. I just can't find it in stores now. I guess it's like a seasonal thing. No, it's not Lisp, Bridgewater. No, don't force us to Lisp. Right. So, what else do I want to say for this coming up? Like, the bounce takes into consideration the distance into the wall the ball is on collision and adds that distance to the ball in the opposite direction. Ball can move at 10 pixels per frame before without clipping through the walls. Yeah, and I'll probably actually limit that a lot lower, so it doesn't clip through bricks as well. When you come to such, can I show you a C++ sure, I guess, yeah. If you want, you can also drop that on Discord. I have a code channel mainly for that kind of thing. But yeah, oh, yeah. I can't guarantee that I'll look at it on stream very in depth, but yeah, you can drop a link to it. Let me try to mail just yet. I feel like there's more than I wanted to say in that commit, but whatever. I mean... If you have a PS2, I mean, I don't have a working PS2. It's broken. I have a PS4 though. IBM Personal System too. All right, so I got that working. That's good. Do I want to try getting the other stuff, the point stuff, work, the other one work? I don't know. That microtracer. You know, let's see how long this stuff actually takes per frame. Not that one. This guy here. And no, come on. Tools, performance profiler, and I'm looking for not that. Update ball sprite. Wow, why does it? Oh no, wait. Okay. What was it again? Check wall collide. There it is. Wow. Okay. That's not as much as reading the controllers. Okay. That's 1/4 or 4 times. I don't know. It's wait for NMI 96%. Yeah, that one. All that does is it's in a wait loop essentially. It's checking a variable over and over and over and over again, and waiting for that variable to change. So that is going to be the longest one. That one takes. Let me drop a breakpoint in there. I'll show you. Wait for NMI. Bit sleeping. Okay. So I marked it, so we'll see it. Bam. All that blue, that's it checking that variable. Don't forget to optimize your idle loop. Yeah. Let's disable NMI to save cycles. Yeah, so that blue, that's actually a dot? Those aren't... Well, I mean, they are lines, but I mean... Those lines are made up of individual dots where it's checking that variable for change. Yeah, so that collision actually happens... Wow. Let's get rid of that. Check, no. Check wall collide. Yeah, let's drop a breakpoint there. Mark it. And come up here somewhere. Drop a breakpoint there and mark that one. Oh boy. Okay. So the first one is over here, scanline 250, scanline cycle 21. Over here, 250 cycle 2. It finishes in a scan line. In a scan line, it finishes. Wow, that's actually a lot faster than I thought it would be. So presumably I could, if my other code for the other collision type is the same speed for each point, I could very easily do that collision check every frame without having to worry about running it too long. So originally I was thinking of like, okay, if it's like above half, if it's in the top half of the screen, we turn on the the brick collision or whatever. I don't think I even need to bother with that. I could just check every frame. Okay, is there a brick there? No. Okay, is there a brick there? No. Okay, is there a brick there? No. Even worse, sometimes optimizing your idle loop improves throughput. Yeah. Every frame, let's go. Yeah. Yeah. 1.79 megahertz CPU. What did I expect? What did I expect? I don't know. I expected it to take like 2 or 3 scan lines at least. But it doesn't, so that's cool. So yeah, so all right. Well, let's actually tweak the sprite a little bit. Right. Let's well, I mean, I'm not gonna be able to do what I wanted to do without modifying more values. I don't want to modify, so let's just do that for now. Yeah. I thought about putting the collision points on that. Actually, you know what? Yeah, I do want to put the collision points on that. So I can see it visually. So these are the points that I will be checking for the collision. You're fired. You're fired. And for the sprite translation, I'm going to, you know, let's also add that up here. Sprite or ball sprite offset x is a number like 3, I think, and y I think is also 3, probably. Yeah, okay. X and Y. Wasn't there a NES Go? Probably. I'm sure there was. Small board subset. So ghosts. So the ghosts seeking completely analyzed. Basic always. go to and go sub. That actually reminds me. I actually put a go-to statement into C# code the other day. It felt so dirty. It felt so dirty, but like, I needed it. I needed it. I needed it. See, there you go. You've got the right idea. Yeah, I'm like, well, I could write like X amount more lines, or I could just use a go-to. So I used a go-to. Don't tell anybody. Here's the really fun thing with basic and go sub, using variables to name your subroutines. Oh. The color didn't change. It didn't. I did it again. I saved it, but I didn't export it. I kind of really want to put the sprite into the build chain. I kind of want to. See, now I've got like, oops, sorry. Now I've got the pixels on there for the collision. And if I just change the palette for some of those to be like more noticeable, so these guys will make that color. In the center, I'll make that color. I see. I picked that up from Turtle Geometry. Huh. You know, let's actually, well, no, I'll keep that as, the gray works, okay. 26, 0, and 30, okay. 26, 0, and 30. It's worth noting that the original go-to harmful thing was actually talking about specific types and uses of go-to, not all of them. That's what I figure. And that's somewhat specific context as well. Yeah. So compared to the last title ball that was, so compared to the last tile ball was on, you know, what side you hit. I mean, kinda. It's also worth noting that the title was assigned by the editor, not the author. Oh, really? This is hard, but really fun. ML using TensorFlow. Took me a couple months to understand the concept behind it. Took me a month to write the model that ran. Took me 50 seconds to realize that my model did. What my model did was useless, and I should make something useful for fun. Took another second to realize I should probably stop with it. So there are some things that actually I'd like to try with that, right? There's even some like NES specific things I'd like to try with that, teaching a program, or yeah, teaching a neural network to play a game, essentially. Other books in this series: A Robot Ping Pong Player. Bet you it's better than the one I wrote for Pong. Right. I did all that. Reassemble that. Over here. Oh. Yeah, that's about right. Why not? What? How fast is it going right now? 3. Okay. So each of these guys is like what? Oh no, they're actually 8. They're actually a solid 8 pixels across. Right? Yeah, they're a full tile. Now I haven't decided on the graphics for these guys yet. So do I want like this border? Do I want that part of the tile? Or no? Should really get back to ML. It's really an ideal path to go down. Very high skill base and good at good playing, I'm sure. And plus it's fun. Yeah. Queen's Graphics is a retro game. Yeah. You know what I actually just realized, Bridgewater? I don't restrict the tiles to the attribute grid. So if I open up not that. This over here. Main boards. Okay, well, it's that, yeah. Come on. And I bring up board 4. Board ID 4. Where's the load board call? This. Redo that. Over here. No, over here. So these do not align to the attribute table. Entirely. So there are tiles that overlap. So I wouldn't necessarily be able to really use or utilize that name table trick we were thinking about before. These graphics is a retro game. Yeah. Hopefully. All right. Thanks for stopping by, Flykin. Hope to see you again. Have a good night. Unix was written by a video game programmer who wanted to mess with the file systems. But did video games exist back then? Like, I'm not entirely sure they did. Did they? Yeah. But so the basis for that raster effect we were thinking of before was that I'd be able to switch between the name tables on every other brick row, or so like every other tile essentially, and I could have two different attribute pieces of data set for each of the name tables, so that would work horizontally, vertically. But if I offset it by a tile horizontally, like here, tiles next to each other would start to get all screwy. Not the game in question with the 1962 date was nice. A space war. That was like one of the first ones, wasn't it? Yes. Yeah, and the PDP 11? No. PDP 1. Never mind. Yeah. Yeah. And you know, so I did actually think, I think I might have even mentioned this on stream. Yeah, 'cause I have them drawn out here as well. I also thought about the possibility of having vertical tiles as well. Admittedly, video games are about a decade old by that point, but still. So yeah, I think I want to leave the possibility of having vertical tiles as well. And for that, I would. I mean, I don't know how I would encode that though. You know, like I know how I would represent that in RAM. I think. So the byte form would be the same with the 2 bytes per brick. They'd be oriented like they would be on screen, and I would have a separate table of like a bit lookup kind of thing, right? Where it's it defines if that specific brick is vertical or not. Now you've got me wondering about the possibility of swapping active name tables every 8 pixels. Problem being you can't actually smack the PPU that fast. Yeah. No. And he influenced the birth of MS as well. In the fall of 1968, he mentored Bill Gates and Paul Allen on the use of the DEC PDP-10 mainframe. Ooh. 16 pixels. I only need 16 pixels. For strictly horizontal tiles, yes. But if I throw vertical tiles into the mix, I would need it at 8. I mean, excuse me. I suppose I can restrict the vertical tiles to like the child boards only, and have those bricks twice the size. Align it to the half attribute boundary. Even for the verticals? I see what you're saying, yes. Yes, I see what you're saying. I think. Yeah, you would align the swap to the half attribute boundary. Yeah, okay. So you'll actually be using all the attribute data on both name tables at the same time, essentially. Because if you did it every, well, yeah. So if you did it only every other row, you'd only be using half of the attribute data, essentially. Well, you'd still be using all the attribute data, but not for all the tiles. I don't know, I can't explain it very well, but I know what you mean. One of each, and the next one you get one of each, and the opposite. Yes, exactly. Yeah. Once I actually thought about it, it made sense. I had to think about it for a second though, in order for it to make sense. Yeah. Can I actually get that effect? I doubt it, actually. Because I tried changing. Remember, I tried changing the background color during the frame, and that didn't work very well. I'm granted that's writing writing some color data to the PVU, and this is changing scroll data. Yeah, I'm not sure I'd have the timing down very well on that. I mean, like, so I would essentially have the top portion of the screen dedicated to precise timing of scan lines and pixels on that scan line, and then after that I would actually run the frame. So I'd have like half the frame-ish to run the game code and the audio and all that kind of crap. 16 pixels is what? 3 1/3 CPU cycles? You would need to run that from RAM, wouldn't you? Too much. It's alright, I can't do math sober. Not necessarily? I don't know. Anyway, I think I might end a little early tonight. 5 1/3. Well, I mean, that's better, but it's only like 2 cycles more. Actually, what haven't I committed? What did I do here? Oh, you know, let me commit these real quick. So let's do all that. Change or add visual collision presentation to ball sprite. But yeah, that's enough to do a store absolute. Wouldn't I also need, well, no, because I'd just load one of the values in X and the other value in Y, essentially. I'll use 2 registers and store X, store Y, store X, store Y, store X, store Y, or something like that, right? In a really tight loop. Or an unrolled loop, probably. Pixels to the ball sprite to represent the collision points. Need to account for the 1/3 cycle skew, but yeah. Yeah, this sounds like it'd be a lot easier with a like a proper scanline counter on the cartridge. Because otherwise, I'd have to like align that with at the beginning and keep it on track the entire time, you know. Yeah. Anyway, I think I'm gonna call it for tonight. I'm ending a little early, but like I went to sleep like way too late last night, so yeah, I need to get off. Not a scanline counter. We're trying to hit vertical blanks. I mean, You mean horizontal breaks? You mean? I don't know. And yeah, so don't go anywhere yet. We're gonna see if we can find somebody, find someone streaming. Find someone online. Breaks, not blanks. Oh. It goes to show how tired I am. I can't even read. But yes, I'll be back on, what is that, Tuesday? I'll be back on Thursday. Thank you, boss. So I hope to see you guys then. But don't go anywhere yet. Let's go say hi to somebody. Who are we gonna say hi to, though? I follow a lot of art streamers. Why do I follow so many art streamers that I can't raid? Well, I can raid, but I mean, you know, I don't know. We're trying to do raster effects that change what name table is involved in an attribute tile fetch on a control basis. Yeah, it's complicated. Alright, so this always like this. It's always the same people that are streaming when I'm done. And of course, there's always the growing channels. Why are there always the growing channels? Let's see. No, voice acting? What's he doing in science and tech? Probably going to be easier to use custom. Yeah, it would probably be easier to use custom hardware for that. Yeah, and have all this the scanline counting and that. I don't think I know that person. Is he live? I'm assuming it's a he with that username. What does he do? Does he do science and tech stuff? Watch repair. Okay. That's different. Yeah, sure. Let's go say hi to this guy. Why not? Yeah. Alright. Yeah, so thank you guys for stopping by. I will see you next time. FPGA cart? I mean, that's not out of the question. I need to type in the raid command correctly, though. That would help. But yeah, so come with me to say hi to this guy. I don't really know who he is, but let's go say hi. I will see you guys next time. Next time, Gadget. Next time. But come with me to say hi to this guy. And you guys have a good night. And thanks for stopping by. See you next time.